Okay, let's dive right into this. We're going to tackle a question that sounds incredibly simple, but wow, it has a surprisingly fascinating answer. What is clay? I mean, we use it for everything from pottery to building materials, but what is it, fundamentally?
Now, if you asked most people, they'd probably say something just like this. And you know what? It makes total sense, right? You just picture rocks tumbling around in a river for millions of years, grinding down into finer and finer particles until you get that smooth, malleable mud we all know as clay. Seems pretty straightforward.
And here's the thing, that common idea is actually really close to the truth. It absolutely nails some of the most important and obvious properties of clay, which is exactly why that idea is so popular.
I mean, this intuition totally holds up when you look at how we use clay. We know it's an amazing building material. We know it's incredibly plastic. You can shape it so easily when it's wet, like on a potter's wheel. And then, when you fire it in a kiln, it becomes unbelievably hard and durable because all those tiny particles literally fuse together. So far, the groundstone idea seems to fit perfectly, right?
But here is where we get to the real heart of it. Is that the whole story? Is clay simply rock that's been smashed into microscopic little bits? Well, as it turns out, the whole grinding part, that's just a supporting role in this story. The main event is something way more transformative.
So, let's explore this. When a rock breaks down over time, it can basically follow one of two main paths. One path is all about pure force, just grinding. The other is a path of fundamental change, of actual transformation. And believe me, that distinction makes all the difference.
And this breaks it down perfectly. Over on the left, you've got mechanical weathering. Just think of it as brute force, rocks smashing, scraping, and breaking each other apart. That whole process gives you things like sand and silt. But on the right, you have chemical weathering. Now, this isn't about force at all. It's about a chemical reaction, where the very minerals inside the rock react with water. And that process, that's what gives you clay. So, to really get this, let's follow that first path for a second. The story of sand. It's a pretty straightforward tale of just physical breakdown.
Here's a great way to think about it. Imagine you built this huge, awesome Lego castle. Now, if you take a hammer and just smash that castle to bits, you get a big pile of tiny Lego pieces. It's still the exact same plastic, just in much smaller bits. That's sand. It's just tiny, ground-up pieces of the original rock, like quartz.
Okay, now let's compare that with the much more subtle and honestly way more interesting story of clay. This isn't a story of brute force. It's a story of chemical alchemy. Let's go back to our Legos. To get clay, you don't smash the bricks. Instead, imagine the plastic of the Lego bricks themselves dissolving in water and then reforming as something totally new, like tiny, flat flakes. It's not even Lego plastic anymore. It is literally transformed into a new material.
And that process has a name, chemical weathering. And listen to the key words here: altered, dissolved, and transforming. This is not about making something smaller, it's about making something completely new.
So, how does this chemical magic actually work? Well, it all starts when water seeps into rocks that are rich in a mineral called feldspar. Then a chemical reaction called hydrolysis kicks off. And this isn't physical grinding. It's the water chemically breaking down and rearranging the feldspar, actually transforming it into entirely new things called clay minerals. And the result is you get these brand new substances, things like kaolinite, illite, and smectite. And these aren't just fancy names. They are fundamentally different materials, right down to the molecular level from the feldspar they started as. This is the absolute key. You haven't just made tiny feldspar. You've created entirely new minerals that have completely new properties. So, why do we care about all this geological chemistry? Why does this matter? Well, because this chemical origin story is the secret to all of clay's magical properties, from a simple pot to a terracotta warrior.
Hey, remember that Lego analogy? The bricks dissolving and reforming into flakes? That's not just a cute model. These new clay minerals are genuinely microscopic, plate-like flakes. So when you add water, these little plates can slide right over each other, and that is what gives clay its signature plasticity, its stickiness. Sand particles, which are just tiny, jagged rocks, could never do that.
So if you take one thing away from this, it should be this. Clay is not simply the dust of old mountains. It is the result of a deep, profound chemical transformation. It's rock that hasn't just been broken, but has been fundamentally reborn into something new.
Which leaves us with a final thought to chew on. The next time you hold a ceramic mug or see a brick wall, just ask yourself,
Are you looking at something made from mere ground-up stone, or are you looking at something made from stone that has been chemically reborn? I think you'll find the answer changes everything.